Direct Memory Access, DMA, is a feature of computer architecture that allows certain devices, such as input-output, I/O, controllers or peripheral devices, to directly access the system memory without involving the Central Processing Unit, CPU. It enables data transfers between these devices and memory without burdening the CPU with the task of managing the data transfer. In a typical computer system, when a device needs to transfer data to or from memory, the CPU is usually involved in the process. The device sends a request to the CPU, which then initiates the data transfer by reading or writing the data between the device and memory. This process is known as programmed I/O. DMA provides an alternative mechanism that bypasses the CPU's involvement in data transfers, resulting in faster and more efficient data movement. With DMA, the device capable of DMA functionality can directly access the memory bus and transfer data to or from memory without requiring the CPU to participate actively. Here's a simplified overview of how DMA works. 1. The device initiates a DMA request by asserting a DMA request signal to the DMA controller. 2. The DMA controller receives the request and gains control of the system bus, temporarily pausing the CPU's access to memory. 3. The DMA controller communicates with the device to determine the transfer details, such as the source and destination addresses in memory, transfer size, etc. 4. The DMA controller directly transfers data between the device and memory, using the memory bus, without CPU intervention. 5. Once the transfer is complete, the DMA controller releases the control of the system bus, allowing the CPU to resume its operations. DMA significantly reduces the CPU overhead involved in managing data transfers, improving overall system performance. It is commonly used for high-speed data transfers, such as disk I/O, network communication, and multimedia processing, where the efficient movement of large amounts of data is essential. It's important to note that DMA transfers still require coordination between the device, DMA controller, and memory. The CPU typically sets up the DMA controller, provides it with necessary parameters, and handles any necessary synchronization or notification when the transfer is complete. DMA simply offloads the data transfer process from the CPU, freeing